Okay. So doing remainder theorem. Still working with synthetic division. This is just like a little extension onto it. And it's going to be great. So remember when we were dividing polynomials, we could write polynomials like this. F of x equals the x minus k times q of x plus r. We wrote it in like factored form, and then I had that extra remainder piece to it. So the remainder theorem basically says, if you know, okay, how do I want to write this actually? Given the value of k, the remainder is the solution of f of k. So basically, in a nutshell, if I plugged in k into whatever the function was, the polynomial, I would get out the remainder. So instead of like directly substituting the k value in, I could use synthetic division, and the remainder is that function value. So I'll show you both ways to kind of figure out what this actually is meaning. But if I plugged in k into this piece, this whole term cancels out except k minus k, so it's 0, and that's why it's equal to just the remainder. Okay? So we're working with remainder theorem, still doing synthetic division, so we're still trying to solve. Okay. So it says use remainder theorem to find f of negative 3. So typically, if you're given f of negative 3, you would just substitute negative 3 in for x. Right? Directly substitute it, figure out what negative 3 to the fourth power is, negative 3 to the second power, and substitute, simplify, combine like terms. Do all things. Remainder theorem basically says I could put that negative 3 into this lovely little box and figure it all out. Remainder is my solution. So for my polynomial, what are all my coefficients?
3, 0,
0.
3, negative 4,
Yeah. And then what do I do first?
drop
Okay, drop negative 1. Okay.
and
Multiply, add. Multiply, add. Multiply, add. Oh, jeepers.
So you don't switch the sign?
yeah.
No. We're going to check it, though, just to make sure. What's negative 3 times 14? Is that negative? 42? 52? Ends with a 2. I think it's 42. Anybody want to check my math?
Yeah, that's what
Okay.
I haven't checked.
Okay. So what this is saying, my remainder of negative 47 is the function value. So basically, if I plugged in negative 3, we would get out negative 47. And we're going to check just because now I'm curious if that's actually right. Okay. So plugging in negative 3, I have negative 3 to the fourth power, plus 3, negative 3 to the second power, minus 4 times negative 3, minus 5. So if I figured all that out, do I get negative 47 like we should? Yeah? Eli says yes. So, check.
Please.
So why don't you change the sign for this one?
Okay, it's because it's not in like x minus something.
Yeah, it's not
just
written as a
something-
factor. I think it's just like k equals
So
negative
it's like
3.
the ones on the assignment where we just
Yeah.
okay.
Yeah. treat it like a factor, then you change the sign. Okay, so we have one more thing that we want to talk about, which ties right into the remainder theorem. So our goal for like the next few days is finding the zeros of a polynomial. So that's why we've been working with synthetic division. So a zero is basically like an x-intercept is our goal. Okay? But I can use the remainder theorem to actually figure out a zero. So I'm going to say a zero first. When the remainder is zero, after doing synthetic division. Okay, so if I would have gotten 0 instead of negative 47, I know negative 3 is the solution to that polynomial. That's where it's going to cross the x-axis. Plug it in, you get out 0. So, here's the next one we want to figure out. Is negative 1 a 0 the solution? 0 polynomial. So basically, if the remainder is 0, then it is a solution. If it's not, then it's not 0. Okay, so k equals negative 1. Negative 1 is inside my lovely little box. And my coefficients are
1, 0, 1, 3.
okay. Cool. Drop the 1 down, multiply, add, multiply, add, multiply, add, multiply, add. Nope. Not a 0 because of that 6 right there. So remainder of 6 makes it not a 0. If it was 0, it is a 0.
So basically, it's working out, and then you can say it is.
Yep. We'll work with these later. Okay, last but not least, just because we have this lovely little k value that's 1 plus 2i, so complex numbers makes it more interesting, basically. Still doing the same thing. We want to do synthetic division and figure out if it's a 0 or not. We're just going to work a little harder. So 1 plus 2i is in the box. And I still want to write all the coefficients down. 1, negative 2, 4, 2, negative 5. This is going to be great fun. Hopefully you left enough space. So the 1 drops down, which is easy part. Then I have to multiply. 1 times 1 plus 2i is 1 plus 2i. Okay? And then I'm adding, and I need to combine like terms. Negative 1 plus 2i. Which is all fine and dandy until I have to multiply by 1 plus 2i. So I would go off to the side and have 1 plus 2i times negative 1 plus 2i. So I actually need to distribute this out. And that's where this becomes not fun because extra work basically. 1 times negative 1, negative 1. 1 times 2i is 2i. 2i times negative 1, negative 2i. 2i times 2i is 4i squared. So the I values cancel. That's nice. Does anybody remember what I squared is?
Negative 1.
Yeah, so make a note, I squared is negative 1. So then I can replace it. I'd have negative 4 plus 4 times negative 1, which is actually negative 5 now. So going back up in the synthetic division, now I have negative 5. And 4 plus negative 5 is. Okay? And we have to keep doing the process. So negative 1 times 1 plus 2i Negative 1 minus 2i. Yeah? Okay, and then we're adding vertically, combining like terms. I get 1 minus 2i. And then on nuts, we have it again, so we have to rewrite it. 1 plus 2i times 1 minus 2i. And distribute. Once again, it was really nice because the negative 2i and positive 2i canceled. And negative 4i squared becomes what? Yeah, just 4, so plus 4. And 1 plus 4 is 5, so that's my last lot. So the negative 5 plus 5 is 0. Yeah, so this is a 0 because the remainder is 0. 0. After all that work, figured it out. We're going to work with more imaginary numbers when we get to the next part of this whole fun thing. Sorry. Okay, well that's what we're doing for today. We're going to be pros at synthetic division. That's the goal.
To the 10th.
Yeah. No. Yes. I didn't change the date. It is the 10th because tomorrow's Veterans Day. Okay, did we write this down?